Here we're going to look at Newton's second law. Now, Newton's second law is actually quite simple. It can be stated as the resultant force acting on an object is equal to the mass of the object times the acceleration of the object. Here's what it looks like. It looks quite simple, and it actually is. The only slight complication is remembering that this force here is the total force, or the net force, acting on an object. So if there's more than one force, this F here is the vector addition of all the forces. Now, since we've been studying dynamics, one of the fundamentals is conservation of momentum. Now, we're going to see how Newton's second law, F equals ma, comes from the idea of conservation of momentum. So we know that the force acting on an object is equal to the change in momentum divided by the time taken, or the rate of change of momentum. Now, two things we know about momentum is A, the definition of momentum. Momentum equals the mass times the velocity, and also that the change in momentum can be calculated using the final momentum minus the initial momentum. Now, using those two facts, we get this. So here, I've expressed the change in momentum as the final momentum minus the initial momentum. We're only going to deal with cases where the mass is constant, the mass isn't going to change. Therefore, we can take that mass out as a common factor, and that's going to leave us with an expression that looks like this. And this should look fairly familiar. It's the final velocity minus the initial velocity, which, of course, can simply be written as the change in velocity. So, knowing that, we can now rewrite this expression as... So, this here should look fairly familiar. It says the change in velocity divided by the change in time. A more scientific way of saying that would be the rate of change in velocity. And of course, we know rate of change in velocity is simply the acceleration. So, that means that this can be rewritten as... So I've just proved it. We've just shown, using momentum, that the force equals the mass times the acceleration. Newton's second law. Now, I like to often think about Newton's second law in a slightly different way. I like to think about it like this. So this expression, just rearrange the equation, shows me that the acceleration of an object is equal to the net force, or the total force acting on an object, divided by its mass. Now this, I feel, is one of the most important equations we can understand when thinking about dynamics, the way things move. Let's look at a couple of examples. So in this example here, we can see that we've got 10 newtons to the right, 10 newtons to the left. So overall, the net force acting on that object is 0 newtons. So straight away, I can tell that this object is not going to accelerate, because there is no net force acting on the object. However, in this case, we can see that there's 10 newtons acting down, and that's the only force, so therefore the forces are unbalanced. There is a net force acting on it, so that object there is going to accelerate, and in fact it's going to accelerate down, because that's the direction of the net force. So that, I think, is the important thing to remember in this case, is that if you have an object and it only has one force acting on it, straight away you know that force cannot be balanced, therefore the object will accelerate. However, if it has more than one force acting on it, then you have to add up all the forces as vectors if there is a net force, if they add up to something that's more than zero, then there's going to be acceleration. However, if all those forces add together and the net force is zero, the object will not accelerate. So that's it. That is Newton's second law. It's quite simple. Can take a little bit of practice to get used to, but once you grasp it, it is such a useful physics idea and will help you solve so many problems. Good luck.